Okay, we'll look at the derivative of a natural log of absolute value of x. In this case, we have the absolute value, which applies for positive and negative values. Let's just take a look at the graph of the ln of natural log of x and the ln of the absolute value of natural log of x, and just notice that natural log is only defined for positive values, and natural log of absolute values applied for positive and negative values. So looking at the graph, here is just the graph of natural log of x. As you notice, it's just increasing, going to the right. It should be going down forever, just that the graphing software cut it off a little bit. So there's an asymptote on the y-axis, and it's just increasing, going to the right. So it's only defined for values larger than 0, and that's just for a natural log of x. And we've already proved the derivative of that is equal to 1 over x. If we take a look at the derivative of natural log of absolute value of x, you notice I have the absolute value bars in there. It's defined for negative values as well as positive values, but not defined for 0, because you can't take the natural log of 0, which we won't go into now. But just notice that natural log for the absolute value can be defined for negative values or positive values, because when you plug in a negative value, the absolute value makes it positive, and therefore a natural log of a positive number is well defined. So we're just going to find the derivative of the natural log of absolute value of x, which we're going to show is just equal to 1 over x. So when you take the derivative of natural log of an absolute value of x, your derivative is just 1 over x, so the absolute value really doesn't have much to do with the problem. In order to determine this derivative, let's just rewrite the absolute value of x as a piecewise function. Absolute value of x is equal to negative x if x is less than 0, and positive x if x is larger than 0. So therefore I'm just going to take two derivatives, if you will. I'm first going to take the derivative of the natural log of absolute value, of negative x. So I'm going to drop the absolute value bars and just write it as the derivative of this one and the derivative of that one, and notice that in both cases we get 1 over x. So using the chain rule and the derivative of natural log, so natural log says when you take a derivative of something, you take whatever your absolute value, whatever your natural log value is, and put that in the denominator. So in this case it's negative x, and then chain rule says take derivative of the inside, which is equal to negative 1. So those two cancel, so we get 1 over x. And so that's the top half of our piecewise function. Now the bottom half is when your values are positive, so we just have x. So our derivative of the natural log of x, well, we already know that, that's 1 over x. So regardless of your negative values according to absolute value or positive values, in either case you get 1 over x. So the absolute value doesn't really change when you're taking derivatives of absolute with natural logs. So let's just look at two examples here. Okay, so we have the absolute value, natural log of the absolute value of sine. So when taking the derivative, the absolute value doesn't really change the problem. So we have dy dx, natural log, you take the function and put it in the denominator. So it's 1 over the sine of x. Notice the absolute value bars is dropped. The derivative of the inside, which is sine, is cosine of x. So we get dy dx is equal to the cosine of x over sine of x. And I believe that is equal to cotangent of x. We'll do one more example, then we'll wrap this video up. Again, the absolute values really have no effect on taking derivative with natural log. So we get dy dx. This goes down to the denominator, so we get the secant of x plus the tangent of x times the derivative of the inside, which is secant x tan x plus secant squared x. I'm going to take a courteous common factor of secant out, so I get dy dx equals secant x tangent of x plus secant of x all over secant of x plus tan x. And notice these two cancel, so I'm left with dy dx is the secant of x. Thanks.